Hey Golden Ones, it is I, the Kobold. Today we're going to start our game development journey by starting a monogame project and drawing our tennis court. You'll learn about the parts of the game class, figuring out what resolutions you want to target, and how to draw. We'll be doing this in 3 parts, so check my video chapter list in the description if you want to skip the specific sections. First off, let's make sure you've got monogame set up on your computer so that you can start developing. A lot of my videos are going to assume that you're using Visual Studio 2019 in Windows to program, but it's fine if you're using something else. I won't go into all the details on how to install monogame for development, but if you haven't already, you can visit the website and follow their instructions. I placed a link to it in the description below. Once you have monogame installed, along with the templates and the MGCB editor, please go ahead and open Visual Studio 2019 and start a monogame cross-platform desktop project. Name it whatever you want, but personally I would name it Pong. Visual Studio will go ahead and create your project and we are good to go. Your project should have a file named game1.cs. Go ahead and open it. Let's go over what all the components the auto-generated file has. At the top of this file we have the using statements. These tell the compiler what namespaces your code file will be using. All libraries will have their own namespaces. Monogame Space Library is the Microsoft.xna.framework namespace, which is a holdover from its roots being an open source version of Microsoft XNA. A little further down, we declare which namespace this code will be in. For now, it'll be named whatever you named your project, so Pong if you followed my suggestion. After that, we declare the class. By default, this will be Game1. The colon after it tells the compiler that we're inheriting from another class, which in this case is the game class. The game class already has a lot of code that manages a lot of things you need to get a game started running. There's a lot of initialization and setup that needs to be done to make a game, and the game class does a lot of it for you. Everything within the brackets is now part of the Game1 class. What we do next is declare some private fields that will be used within the class. A field is a variable that can be used by code that is specific to that instance of the class. The private keyword makes it so only stuff inside the class has access to these variables. By making it private, you know that only the Game1 class can change these values. These 2 fields are kind of important to monogame coding, so they are generated automatically. The first stores a graphics device manager object, which handles changing window size, changing it to full screen, and all that. The next stores a sprite batch object, which is what we will use to draw to the screen. This is the constructor. This is what is run when a class is created. Note that it has no return value and that it is the same name as the class it is constructing. In it, the graphics device manager is constructed, we set where the content files are located, and we set the mouse cursor to being visible over the window. There are 3 new keywords here too. First off is public, which just means that it is accessible outside the class. This is so other objects can create this object. Then we have the new keyword. It is how we know that we are running the constructor and not just referencing the class. Finally, we have the this keyword. This refers to the object the code is being called by. In this case, it's the new Game1 object. Next, we have the initialize method. We override because it's already defined by the game class. Initialize is called after the graphics device is initialized but before you load your content. In fact, the game class version of initialize actually calls the load content for game and any game components. That is why we must call base.initialize in this so that it can continue to do so. This method is protected, which is like private, but it means it can also be called by classes that were derived from it. I already mentioned it, but this is load content. This is where you should load any content necessary for starting your game. For now, it just creates the sprite batch object. Here's the meat and potatoes for action. The update method is called 60 times a second by default, and it's where you're supposed to put your game logic. It takes a game time object as a parameter, which stores both how long the game has been running and how much time has passed since the last game update. You can use this to ensure that movement happens smoothly, even if you drop a frame. The only real code in the update method right now checks the keyboard and the first gamepad to see if the player wants to exit, and then it exits The base version of the update method iterates over any game components, so you should probably always remember to call base.update here. Finally, we have our draw method. It takes a game time just like update, and is where you should call all your graphical code. By default, it clears the screen to a pretty blue color, and then calls base.draw, which iterates over any drawable game components and has them draw. Make sure to close your brackets. Don't worry, I'm just pausing the video here to thank you for joining me today. This channel is in its infancy, and if you like what you've seen so far, make sure to leave a like and subscribe if you haven't already. I post content weekly, related to games and development, and would certainly like you to join me in the future. Alright, let's get back to the video. One of the first things you should decide before starting any project is figuring out what resolution you want to target. The resolution will inform all your decisions from art to layout, and it's important to have it in mind when you start. While consoles have stayed pretty consistent with supported resolutions, and desktops to a certain extent, the mobile market has a wide variety to choose from. In front of your eyes is a chart of some common resolutions, but make no mistake, they are way more than I'm showing you now. Think about what market you want to target, and what makes sense for your project. If you're going for PC, it doesn't hurt to choose something 16:9 aspect-wise. Most monitors are, or are close to this aspect ratio. If you're targeting cell phones, know that while 16:9 fits pretty okay with lower-end models, the higher-end phones typically have much wider displays. Screen orientation also matters. A game made to fit in portrait 9:16 may not look right if you let it go to landscape 16:9, so start thinking about that as you start. As I went over last video, Atari's Pong used a retail TV to display their game. I know that while the specs boast 858 by 525 resolution, the vertical scan lines that are visible on one of those TVs was actually 486. I don't know the specific timings of Pong, but I believe 858 horizontal is probably larger than it was in practice. So I'm just going to assume it's 4:3. Since I'm going to make my game like the original Pong, I've picked out the resolution 640 by 480 to base all my graphics around. It's close enough to the original that I will be happy with that. With a 4:3 ratio, how are we going to make sure that we keep true to that when displays may be any number of aspect ratios? We're either going to have to pillar box or letterbox our display. This is where you see black borders on either the left and right or the top and bottom. It allows us to only show a portion of the screen in the aspect ratio. Let's go over some math. With pillar or letterboxing, one dimension of the drawing rectangle has to fill the whole of the same dimension on the screen. So first we have to isolate which dimension can be filled. So I'll check if the width of our screen divided by the width of what we want to draw times the height of what we want to draw is larger than the height of our screen. If it is, we can't fit our drawing on the screen if we use width as our determining factor, so we figure out our new width to draw on. We do that by taking our screen height, dividing it by our height, and multiplying it by our drawing's width. If it happened to be smaller, we instead do this to the height. This will give us the largest rectangle that we can fit our aspect ratio in this screen size. Easy peasy. Now that we have a resolution we want to target and understand what the game class wants from us, let's get something running. At the top, make sure you add the system's namespace to your using statements. This namespace houses a lot of standard classes that are commonly used by Mono and .NET projects. We declare these three private fields. The render target 2D will be used to draw our game before it's drawn on screen. The rectangle we use to figure out where on screen the render target will be drawn. And the texture 2D will hold a white pixel texture that will draw a lot of our stuff. In the constructor, I add these two lines. By changing the target elapsed time field of the base game object, we change how often we want our update loop to be called from 60 times a second to 30. The original Pong updated about 30 times a second, so we're copying that. Other than that, we are setting the window to be allowed to be resized so that we can show off how pillar and letterboxing works. In the initialize method, we do a few things. First off, we construct our render target to be 640 by 480. Next, we tell the graphics device manager we want the window to be 1280 by 720 and not full screen. Make sure when you update these values you call apply, or it won't take effect. Finally, we add and call a delegate method that will be called when the window size is changed. Here is that window change method. Don't worry about the parameters, as they aren't important for our uses, but they need to be there so we can add it on to this event. This defines our pillar and letterboxing as I described before. In the load content method, we need to create our texture. This code isn't as important to know what is happening, as creating a texture manually isn't something done often with monogame development. But basically, I create a 1x1 texture object and set its color data to 1 white pixel. We can do a lot with 1 white pixel. Finally, we draw our tennis court. So to draw on our render target, we have to set our graphics device to draw on the render target. We clear the render target to black so that we can draw white over it. We then start our sprite batch. Sprite batch bundles up all our drawing calls and puts together texture calls to speed up drawing, so you always call your draw calls between a start and end call. We set up a for loop to draw our net. A for loop will iterate over some commands while changing an iterator's value. When the iterator reaches a certain value, it will stop and continue on with the code. In this instance, we will iterate 31 times, drawing a dotted line down the field. This particular overload of SpriteBatch.draw takes a texture, a rectangle for placement on screen, and a color. The rectangle's X would be a value between 0 and 639, with 0 being the left and 639 being the right, while the rectangle's Y would be between 0 and 479, with 0 being the top and 479 being the bottom. Knowing how screen coordinates work is important for placing graphics where you need them. After iterating over our net, we end the sprite batch. By ending it, it now draws what we called, but since it's drawn to our render target, we now need to draw that to the screen. So, we set our render target to null, which means no object, so that the graphics device now knows that we want to draw to the screen. We clear this to blue so that you can see how the screen changes as you resize it. We start a sprite batch and we draw our render target to the screen using the rectangle we calculate when the window changes size. After ending the sprite batch, boom, we are done. You can now compile and run it. Congratulations! You have drawn a net to the screen, and the game display stays the same aspect ratio no matter what the window size changes to. How was that? Next week, we'll get something more akin to a game playing. Did you learn anything today? What resolutions would you target? Answer me down below in the comments. Today was a lot of setup for some fun times ahead, so I hope you join me next week. Thanks for viewing, and as always, stay gold, code bold, and bear well from the Code Bald.